This is Ham College, episode 108, for January 5th, 2024. Ham College is brought to you by Icom. This winter, make your gatherings merrier, your message clearer, and your connection stronger with Icom. Hi, welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got questions tonight.
Do we have answers?
A few.
Do we have correct answers? A few?
A few, yeah.
Yeah, that's what I was waiting for.
We may have some wrong ones. You know, we like to have a little variety there.
Oh, yeah, got to keep it interesting.
It's near the 1st of January and of 2024. We're recording this. Running a few days late, but...
Yeah, holidays kind of set us back a little bit, but we'll be back on schedule by next month.
I think so. What did we talk about last month? Do you recall?
Oh, let me think about that for a minute. I think we talked about practical wire antennas, like folded dipoles, phased arrays, let me think, effects of ground near antennas.
It could be.
Something like that.
This month we're going to talk about Yagi antennas, parabolic reflectors, circular polarization, loading coils, top loading, feed point impedance of electrically short antennas, antenna Q, and RF grounding.
Is it Yagi or Yagi?
I don't know, but it's a lot of things tonight. A lot of different antenna-related subjects.
I can feel the buzzer heat coming off of it right now.
Oh, you'll get all of these.
Do you think?
Every last one of them. No. Yeah. I don't know.
Maybe. Depends on how my luck's running tonight.
I don't remember who answered the first one last time around.
No, it don't really matter. I'll take the first hit. It don't matter.
All right. Well, let's try it. How much does the gain of an ideal parabolic dish antenna change when the operating frequency is doubled? A, 2 dB.
I meant to say I'll read the first one. B, 3 dB.
C, 4 dB.
Or D, 6 dB. How much does the gain of an ideal parabolic dish antenna change when the operating frequency is doubled? I think I probably picked the wrong one to start with.
Nah, just pick an answer.
I'm gonna go with B, but I don't know. That's probably not right because that seems too obvious. What's everybody saying?
The guys in the chat room are saying D.
D.
Yeah. Let's see. I'm going to agree with them, I think.
Okay. Yeah, there it is. I can feel the heat coming off that buzzer already.
You know, it's good to hear that buzzer every now and then. It's like keeps us honest.
Yeah.
You want some explaining on this one?
Yeah, sure.
Well, I don't really have much, but I got a little bit.
Yeah. Okay.
The gain of a parabolic dish is directly proportional to the square of its diameter and also directly proportional to the frequency of operation. So gain will increase by 6 dB if either the dish's diameter or its frequency is doubled. That just seems like it ought not be that easy, doesn't it?
Yes, it does seem like it shouldn't. You see why I came up with 3, though?
Yeah, because when I was getting all this stuff together, that's what I came up with.
Oh, yeah.
That's why I went with 6 this time around.
How can linearly polarized Yagi antennas be used to produce circular polarization? A. Stack 2 Yagis fed 90 degrees out of phase to form an array with the respective elements in parallel planes.
B. Stack 2 Yagis fed in phase to form an array with the respective elements in parallel planes.
C. Arrange 2 Yagis perpendicular to each other with the driven elements at the same point on the boom, fed 90 degrees out of phase.
D. Arrange 2 Yagis collinear to each other, with the driven elements fed 180 degrees out of phase. How can linearly polarized Yagi antennas be used to produce circular polarization? Let's see. This would be vertical polarization. This would be horizontal. So to get circular and linearly polarized Yagi antenna, so it's going to be more than one Yagi. So I guess we want one horizontal and one vertical.
Mm-hmm.
So I'm going to say C, arrange two Yagis perpendicular to each other.
Yeah, that's what I think too.
With the driven elements at the same point on the boom, at the same distance down the boom, fed 90 degrees out of phase. I think that is the answer.
I think that's the answer too.
You concur?
I do.
Okay, everyone in the chat room concurs. As a matter of fact, I think more answered this time around than last time.
Well, there you go.
There we go.
All right, I'll give up on those. You did it.
Two Yagi antennas on the same boom, mounted perpendicular to each other, and the driven elements in the same location.
Cool.
Okay, here's one you can redeem yourself.
I've actually got circular polarized antennas. They actually have a loop, like a clover, almost like a clover leaf looking. And they actually go on my drone for the video.
Oh, I was wondering what you would have those for, but yeah, okay. Our all our FM broadcast antennas are circular polarized.
And some are right hand polarized, some are left hand.
We don't discriminate
Funny.
on the public airways. No, I don't know if they're right or left. I don't know that it matters.
Well, it matters on the drone,
Well,
but I think that's a different. I don't
yeah.
know. That's kind of different configuration.
Yeah,
Anyway, I might bring one of those sometime for show and tell.
that'd be good. Where should a high Q loading coil be placed to minimize losses in a shortened vertical antenna? A, near the center of the vertical radiator.
B, as low as possible on the vertical radiator.
C, as close to the transmitter as possible.
Or D, at a voltage node. Where should a high Q loading coil be placed to minimize losses in a shortened vertical antenna? Since most of the examples I can think of, they're in the center of the vertical radiator, I'm going with A.
I'm going to agree with you.
I wasn't thinking HF. I guess I should have, but I know all my mobile antennas that had a coil in them. It's in the middle.
Well, all my AM broadcast antennas, all the matching's done at the base. If you got a coil, it's at the base.
Yeah.
That's probably because it'd be difficult to put a coil in the middle of a, 200-foot stick of tower. Oh, it's near the center of the vertical radiator is, most folks in the chat room said, hey, there's a few
Am I going to
B's.
be 2 for 2?
Yeah, a few more B's. Okay, it's leveling up there.
As low as possible.
Well, are you changing your mind?
No, I'm going to stick with the first answer.
There you go. There's an example right there. You put the coil in the middle. That's not exactly the middle, but it's not the bottom either. It's not a ham antenna either.
No, but it is a coil.
Yeah, that's one of those CB antennas. So you know that 5 watts, when you put it on a big coil like that, it's got to be better.
Oh, yeah. Bigger is better anyway, right?
Yeah, that's... except when it comes to frequency and reality.
Yeah. I got a good one for you right here. Been saving this one up for you. Why should an HF mobile antenna loading coil have a high ratio of reactance to resistance? A, to swamp out harmonics.
B, to lower the radiation angle.
C, to minimize losses.
D, to minimize the Q. Why should an HF mobile antenna loading coil have a high ratio of reactance to resistance? A, to swamp out harmonics. No, it's not going to do that. B, to lower the radiation angle. I think it's going to have any effect on that. D, to minimize the Q. No, I think you'd want to maximize the Q on a mobile antenna because you short antenna anyway. So I'm going to say it's C, to minimize losses. I think that'd be your main concern there. So I'm going to go with C. Chat room, a little mixed on it.
Yeah, see a couple D's in there, but mostly C's.
You said A?
No, I did not say A. I think it's C also. That's one that
Okay.
kind of makes any sense.
There you go. It is C. And I do have something to say about that. A short mobile vertical antenna has a decreased radiation resistance and increased capacitive reactance as frequency lowers. The capacitive reactance can be canceled and the antenna resonated at the operating frequency by adding a loading coil. Placing the coil at the bottom of the radiator requires less inductance and produces a wider bandwidth than moving the coil higher on the radiator. That sounds kind of contrary to what we were saying. That sounded like it's better to have it at the bottom.
Uh-huh.
As the coil is raised, the inductance must be increased and the bandwidth decreases. That doesn't sound good, does it?
Mm-mm.
However, the Q of the antenna is increased and losses are minimized as the coil is raised. The best compromise is to place the loading coil midway of the radiating element. So there are some advantages to it being at the bottom, as you don't need as big an inductor and you got a broader bandwidth. But for efficiency, yeah, you better having a narrower bandwidth or a higher Q by raising it, even though you're going to need more inductance. By increasing the Q, you're going to resonate that antenna better at the frequency you're interested in. What usually occurs if a Yagi antenna is designed solely for maximum forward gain? A, the front-to-back ratio increases.
B, the front-to-back ratio decreases.
C, the frequency response is widened over the whole frequency band.
Or D, the SWR is reduced. I don't think it's D.
Okay.
Frequency response is widened. I don't think it's C either. It's going to be either A or B. Designed solely for maximum forward gain. I think that means front to back ratio. I hope I'm not getting these inverted. But I think that means the front to back ratio is increased. It means more power out the front, less out the back. So I guess I'm going to go A.
A.
I think that's right.
Yeah, the chat room would not be a big help to you on this one. This is a very tricky one right here.
Yeah, well, the wording's kind of messing me up a little bit.
Yep. Well, I mean, there again, when I was getting all this stuff together a week or two ago, I said A.
God,
so
come on.
I would have been wrong right with you.
It decreases.
It's B, the front to back ratio decreases. That doesn't make any sense at all, does it?
How can that be?
You would think if you're designing it solely for maximal forward gain, the front to back ratio would have to increase.
Right.
Yeah, I mean, that's what makes sense. However, it's not just what's coming out the front and the back, it's what's on the sides too. So you can take more away from the sides and put it on the front. Or you can spread it out a little wider, but I don't really have a good answer for you other than to say if you're solely designing it for maximum forward gain, you're going to lose a little front to back ratio. What I read, there's a big trade-off when you're designing a Yagi as to what parameters you're designing for. You try to increase one thing and you decrease something else. Everything is very interactive on it. Chat room, yeah, there were a lot of buzzers going off that time. So you were in good company.
Yeah, well, that don't make me feel much better.
Well, everybody just about. There were a few that got it right. But the majority say the front to back ratio increases. And that's just what you would think when you read that question. I mean, that's the one that makes the most sense, but it's not the case.
Sometimes things just don't make sense.
Yep.
Okay. What happens to the SWR bandwidth when one or more loading coils are used to resonate an electrically short antenna? A is increased.
B, it is decreased.
C, it's unchanged if the loading coil is located in the feed point, or at the feed point, rather.
D, it is unchanged if the loading coil is located at a voltage maximum point.
You can answer it?
Oh, is it my question? I'm sorry.
I can try it.
Wait a minute.
I just had a buzzer on the last one.
You did?
Yeah.
Oh, sorry. B, it is decreased. You think, and my reasoning here, what happens when the SWR bandwidth, when one or more loading coils are used to resonate an antenna or electrically short antenna? If we're putting coils in there, we're kind of tuning that circuit. So it's not going to be as broad. So
I think it's B also.
That's why I'm going with B. The chat room, they're all saying B. It's decreased. And did I have anything else to say about that? No, that's about it.
That was enough, huh?
I mean, it's a resonant circuit. Well, the antenna itself is resonant. But if it's too short, it's not going to be resonant on the frequency you want. It's going to be resonant on a higher frequency. You add a coil, then you start, well, you decrease your bandwidth because the coil and the antenna are kind of working as a tuned circuit together. And that's all I got to say about that. What do you say we take a quick break?
I think that's a great idea.
And we'll come right back.
Why don't we give something away when we come back?
That's an even better idea.
This winter, make your gatherings merrier, your message clearer, and your connection stronger with Icom. Whether inside the ham shack or on the air in the great outdoors, Icom has the radio every ham wants. The ID 5100AD is innovation and mobility taken to the next level. Designed from user input, the ID 5100AD offers an intuitive user interface experience with an industry-leading touchscreen display. This radio is one of the most advanced dual-band mobiles on the market today. The ID52A is a VHF-UHF dual-bander with D-Star and FM dual functions and is the first handheld amateur radio with a full-color 2.3-inch waterfall display. The new ID50A gives hours of fun and enjoyment working your favorite bands. Easy D-Star settings, band scope and waterfall display, voice messaging, share picture function, and it uses the same optional accessories as the ID52A, ID51A, and ID31A. Explore the world of microwave with Icom's new SHF portable, the IC905. This all-mode rig covers 2 meters through 70 centimeters, 1.2 gigahertz, 2.4 gigahertz, 5.6 gigahertz bands, and with the optional CX10G transverter, 10 gigahertz. Aim higher and enter the world of SHF. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This is the radio that changed the way entry-level HF was designed. The real HF fun starts here. For the mobile and outdoor aficionados, Icom's IC7100 is road ready. At home or wherever you roam, Happy New Year from Icom. For more information about Icom's amateur radios and to locate a dealer, visit icomamerica.com/amateur.
Back in the old days, we used something called tape. Now, this was a reel-to-reel. Now, a lot of people probably are going to watch this know exactly what we're talking about. And back in the 70s, I would say this was the real big thing, and people were transferring their music to. When you say kind of preceded the 8-track tape,
They were both around at the same time, but yeah, this was the standard for quality. Is that your streamer down there?
that's the streamer down there. That innocent-looking 1.8 gigahertz standard desktop computer, generic, IBM clone, whatever you want to call it.
What do you say we give away something?
Hey, look what I found. How about one of these?
That looks good to me. It's a little wrinkled.
We'll get you a good one that's maybe not quite so wrinkled. If it is, you can iron the wrinkles out of it.
You can get a new one.
Yep. A nice Icom Ham Crew t-shirt. Look as good when you leave the Ham Fest as you did when you got there.
And Jesse's going to stuff some other things in the box as well.
Yep.
So,
No telling what, but it'd
yeah.
be some cool stuff, I'm sure. He usually does.
nice little swag package. If you'd like to win that, how could you do that?
All you got to do is send an email. You don't really even need a call sign or anything. Just send an email to hamcollege@AmateurLogic.TV. If you want to leave a note in there, that's cool. But if you don't want to put a note, it's not required.
Yep. We drew a winner. Right?
Winner chicken dinner?
Yep.
Who's the winner?
A second ago. It says, "Hey there, George and Tommy. Almost ready to take my extra. Y'all's been a big help. I take it on 118. Oh, so he doesn't have long before he'll be an extra. Take care in 7-3. Tommy Thompson, K4OCN. Well, congratulations, Tommy.
That's an interesting name. I used to go to school with a guy named Tommy Thompson when I lived in Virginia. I'm going to have to look the call sign up, see where he is.
I did too, but it was in Mississippi. He must really get around.
It must. That's a 4 call. Isn't that Virginia too?
I
think
didn't
it
look
runs
it
all the
up
way
to see where he is. What is an advantage of using top loading in a shortened HF vertical antenna? A, lower Q.
B, greater structural strength.
C, higher losses.
Or D, improved radiation efficiency. What advantage of using top loading? So that would be the coil at the top in a shortened HF vertical antenna.
You ever seen that?
No, I was just thinking about that. I don't think I have. It doesn't seem very practical for a vertical with the coil at the top, because the HF stuff's usually kind of big, but maybe it is. I think you would have improved radiation efficiency, though, with that coil being up at the very top. It's more wire higher in the air, right?
Yeah, I don't ever recall seeing one on the top either.
I'm assuming this is a theoretical question.
Oh, it's a real thing.
The advantage of using top loading in a shortened HF vertical antenna.
So,
Well, higher losses is not an advantage.
no, that's not an advantage.
So it's not C. I don't see how greater structural strength can come from having a coil at the top of an antenna of a vertical either. So it's not B. Lower Q, I don't think so. Didn't it say earlier? I don't remember that one for sure. I'm still going to stick with D. I don't know if I'll probably get the third buzzer of the night, but I feel like that's the answer.
No, I think you got a good answer there. The chat room does too. There you go.
Oh.
Improved radiation efficiency. However, there was a little flaw in your reasoning there. Well, maybe not in your reasoning, but top loading does not refer to a coil at the top. It just means there's some reactive element up there loading the antenna. It's actually capacitive, a capacitive top hat.
Oh, okay.
And, I just happen to have one of these in the swamp.
Do you?
I do. That's a guide AM broadcast antenna. And you can see those little white spots in the guy wires there are insulators. If you start at the bottom and go up everywhere guy wires are attached, you notice there's some white insulators there. At the first guy, up at the second guy point going up,
Yeah.
see there's some white insulators. But you look at the top, there's no white insulators. Those wires at the top there are connected directly to the tower, and then that is a tuned length of guy wire coming down that's actually top loading. That's a capacitance hat. Then you see the insulators, some longer insulators there. So those top 3 wires are part of the antenna until it gets down to the insulators. So that adds capacitance to the tower. And that would be an example of top loading right there.
Interesting.
Top loading an antenna radiator is accomplished by attaching a capacitive top hat, usually wires extending perpendicular from the top of the radiator. Well, in this case, you couldn't do them perpendicular because, I guess you could, but it's usually done this way right here. This antenna the tower is too short for the frequency it's operating on, so they top loaded it. The added capacitance reduces the resonating value of inductance and the size of necessary loading coils. A smaller inductor reduces the coil's resistive losses and improves antenna radiation efficiency.
What are those white things made out of, the insulators?
All the other insulators on this tower are ceramic. However, those right there are made out of something like fiberglass. You notice they're a little longer.
They have to be pretty strong.
Yeah. You'll see them on power lines a lot. When you see a long white insulator up near the top of a power pole, it's essentially the same kind of insulators used in this particular tower and others I've seen too.
Pretty cool. Thanks for showing that. That's
that's a real world case there.
Yeah.
And there are a lot of AM antennas done that way. Now, some people think, it really increases the antenna's ability to radiate, but there's another school of thought that says, no, it really doesn't. It's just tricking the transmitter into thinking it's operating into an antenna the correct height. So I'm going to kind of stay out of that, but no, that's...
You want to talk about grounding next?
Maybe. If you need a 300-foot antenna, but instead you use a 200-foot one and you top load it, I don't think that's going to work as good as a 300. Just.
Oh yeah.
That's just my thought.
I don't see how it could.
Well, it's all going to tune out to be the same. But the angle that the radiation is coming off that tower is going to be different if the tower is shorter. That's my thought.
What happens as the Q of an antenna increases? A, SWR bandwidth increases.
B, SWR bandwidth decreases.
C, gain is reduced.
D, more common mode current is present on the feed line. What happens as the Q of an antenna is increased? Well, it doesn't change the common mode current present at the feed point. The gain is not reduced. SWR bandwidth is going to decrease because now...
Yeah, you touched base with this one earlier.
If we're increasing the Q, we're resonating more on the frequency we want, but the overall bandwidth is going to decrease. I'm going to say it's B. In the chat room, mostly B.
That was my answer.
There we
Mostly
go.
B.
Wasn't that your rapper name?
Yeah, mostly B. Yep. That's my third gig.
Oh,
I'm dean at Ham College, but my part-time gig, I'm dean at MIT.
yeah, but it's upside down. That's WIT, I think. What is the function of a loading coil used as part of an HF mobile antenna? A, to increase the SWR bandwidth.
B, to lower the losses.
C, to lower the Q.
Or D, to cancel capacitive reactance. The function of a loading coil. Well, we just said it decreases the SWR bandwidth, so it's not A. Lower the losses? I don't think so. To lower the Q? Well, we just said the coil will raise the Q, which is the same as lowering the SWR bandwidth, or the same result, or another result of it. So I'm going to go with D, to cancel the capacitive reactance, because it's not A, B, or C.
Okay. Chat room? Mostly D. Mostly.
See a B in there.
Yep. There you go.
Nailed it.
To cancel capacitive reactance, because a coil is the natural enemy of a capacitor.
Yeah?
Well, sort of. Yeah, a coil has a positive reactance and a capacitor has negative reactance. So you put the two together and you could end up with no reactance. Or you will at a certain frequency, at the resonant frequency.
What happens to feed point impedance at the base of a fixed length HF mobile antenna when operated below its resonant frequency? A, the radiation resistance decreases and the capacitive reactance decreases.
B, the radiation resistance decreases and the capacitive reactance increases.
C, the radiation resistance increases and the capacitive reactance decreases.
Or D, the radiation resistance increases and the capacitive reactance increases.
Wow.
What happens to the feed point impedance at the base of a fixed length HF mobile antenna when operated below its resonant frequency? All right.
HF mobile below.
Yeah, HF mobile. Most of them are going to be short. You're going to be operating below the resonant frequency. So I think your radiation resistance is going to decrease because the antenna is too short. And the capacitive reactance, it's going to increase. I'm going to say it's B.
I see 3 different answers in the chat room.
And it
Oh,
is.
you got it.
Let me tell you how I figured that.
Yeah.
First, the antenna's too short, so the radiation resistance is going to decrease. If the antenna was a full quarter wavelength, your radiation resistance, be in the neighborhood, not exactly 50 ohms, but in that direction. If you make the antenna too short, the radiation resistance goes down. Now, how did I figure the capacitive reactance increases? Well, it does, but what I was thinking, okay, the antenna's too short, so to make it appear longer, I'm going to add a coil to it. So that coil is going to offset the increased capacitance. So capacitive reactance would have increased, and I need to cancel that out.
Well, that makes sense.
Yeah. Basically, you want your antenna to have no reactance, or as low reactance as you can, neither capacitive or inductive. Which of the following conductors would be best for minimizing losses in a station's RF ground system? A, resistive wire such as spark plug wire.
B, wide flat copper strap.
C, stranded wire.
Or D, solid wire. Which of the following conductors would be best for minimizing losses in a station's RF ground system? That's going to be B, wide flat copper strap, because I think, at least I think, because of the skin effect, there's more outside surface, more surface. I'm going with B on that one
I'm going to agree with
for
you,
that reason.
and I think that is a good reason.
They didn't forget
And
everything.
it is. No.
Which of the following would provide the best RF ground for your station? A, 50 ohm resistor connected to ground.
B, an electrically short connection to a metal water pipe.
C, an electrically short connection to 3 or 4 interconnected ground rods driven into the earth.
Or D, an electrically short connection to 3 or 4 interconnected ground rods via a series RF choke. All right, which would provide the best RF ground for your station? Obviously not a 50 ohm resistor connected to ground, because that's going to put at least 50 ohms between you and ground. That wouldn't be a good thing. An electrically short connection to a metal water pipe. That would be a ground, but not the best. D, an electrically short connection to 3 or 4 interconnected ground rods via a series RF choke. Now that RF choke that's going to be between you and the ground. So that thing's got a resonant frequency. You don't want to tune the ground system necessarily. I think it's most direct. And C, an electrically short connection to 3 or 4 interconnected ground rods driven into the earth. Chat room, yeah.
I concur.
Everybody's saying C in there. And it is.
It's the only one that really makes much sense.
Yeah.
Well, for the best ground. I mean, I've grounded things to a water pipe before.
Well, because that's all you had.
But having ground rods, 3 or 4 driven right into the earth.
Yep.
It's going to get much better ground than that.
Yep. I got a little story.
Oh, yeah?
We reckon we got time for a little story?
I think so.
Yeah.
We could take time.
Okay.
Always got time for a good story.
All right. Well, here's a little story. I was doing some contract work for an AM/FM radio station in Greenwood, Mississippi. I was working at the TV station, but on the side I was doing some engineering for this radio station. Yeah, my side hustle. The station had probably the worst RF interference, RFI, that I have ever seen. It was a 100,000 watt signal, effective radiated power, off of like a 200-foot antenna, which meant the antenna is real close to the building. You know, a lot of the RF is, and it was an older antenna too, so the RF was, it was just pounding the building, you know. And they had ground rods and wires and stuff run everywhere through there, but still just horrible RF. You could hear the FM station anywhere you went in that building, and some of the AM in places as well in there, any piece of gear. So I got to scratching my head trying to figure out, well, why is this so bad? Maybe the ground system is bad. And I started tracing around where all these ground wires running. They didn't use copper strap like they should have. It was wire and maybe some copper pipe. But it was running through the troughs in the building. It all came to one point and went outside the building into a little pump house. When it was built, I guess it was before it was in the city limits, so they had a water well there. All these ground connections in the building ran outside into this little pump house and were connected to the water pipe.
Wow.
That was the ground system. And I'm sure there was some stuff under the ground too, but that's where everything in the building was going to. Well, apparently they had a freeze at some point that water pipe cracked,
Oh.
and they patched it back with PVC, so it really doesn't even connect to
It
the
had no
ground. Yeah.
Wow. It seemed like it was pretty inadequate, even with
Well,
was
it
intact.
would have been, but it'd been better than
the nothing they had.
nothing. Yeah.
Wow.
Let's
So what'd
see.
you do to fix it? Just drive a ground rod and hook it up, or did they grind it all right?
I think I probably took a jumper and shorted across it because that's the only thing I could do at the time. And I never really solved that RF problem. I don't think anybody else ever did. It's just too close. I mean, you can't put out 100 kilowatts only 200 foot away from,
It seems like you would probably exceed the maximum RF exposure limits there too, like on a daily basis.
It'd be something you'd want to think about. Yeah. Yeah.
Wow.
But that used to be a common situation because when FM first came on, it was mostly AM stations adding an FM signal, and they were putting the antennas on their existing AM towers, and most of them are, 200 or 300 foot tall. Your antenna, well, you're going to use a smaller transmitter and put as many bays on your antenna as you can to amplify that so you don't have to run as much power. Well, when you do that, the antenna gets longer, so you could end up with a 200-foot tower, and the antenna itself is 80 or 90 foot long coming down, so it's not even 200 foot away. It's closer to the building than that. I think that's it. I think that's the last question for tonight.
So soon?
That was 12. What are you
went by
saying?
Pretty fast.
Thank you, sir. May I have another, please?
No paddle. Wow.
Yep.
It seemed like it went by pretty fast.
Yeah, reasonably. We got on through them. Only one buzzer tonight.
No, two.
Two? You sure?
I was keeping score.
Oh, okay.
You got 9. I got 2. So
Well,
next month, it's your turn.
Okay. I'll see if I can do better.
Okay.
That Icom t-shirt looked mighty nice there to be going to a ham fest. And as a matter of fact,
Oh, yeah.
you and I don't know. I haven't looked at the calendar. We may be going to a ham fest before or just right after the next episode of Ham College.
Probably
right after.
Right after.
Yep. The Jackson Ham Fest is going to be on Friday, February the 2nd and 3rd. So, yeah, we'll probably have a Ham College before then. Just right before then. And I'm thinking about what I need to wear. I don't know what the weather is going to be like then yet. It's anybody's guess.
Yeah.
But what if my Icom t-shirt is in the laundry basket?
Oh, your Ham Crew t-shirt?
My Ham Crew. Yeah, and and I need to look my best.
That would be a travesty.
That would.
So,
what could a fellow do?
Well, you could go to our swag store. We got t-shirts. If the weather's colder, we got longer shirts, jackets, all kind of things on there, hoodies. Go to shop.spreadshirt.com/AmateurLogic. Bet you can find you something pretty sharp to wear to the Hamfest there.
I bet you could.
Probably find you a cool mug to carry some coffee or a spot of tea.
Like this mug right here.
No, not like that one that don't have any writing on it.
Yeah. Oh, you mean one with actual logos on it?
One with logos on it.
Okay. Cool. I'll keep that in mind. As you go throughout the month, you might be thinking, I'd like to converse with some of the other students.
Socialize?
Maybe a dean, maybe a professor. There is a place you can do that.
It is. There's several places. First of all, you can go to facebook.com/groups/Ham College.
Or you could follow at Ham College on X, or formerly Twitter.
Or we could go to Groups.io. Thank you. groups.io/G/AmateurLogic.
That would be a good place as well. And there you can find out what people are talking about, friends of the shows here. And we'll post in there when the next episode is going to be, when we'll be shooting live, when it's been released and is available for download or viewing. And, maybe an occasional project on what we're working on or just interesting tidbits we run across.
Yeah. A lot of people post on there.
Oh, yeah. Yep.
Anyway, it's a pretty fun place to hang out.
It is. If you were wondering what we covered in a particular episode, say you're a little rusty on practical wire antennas, folded dipoles, phased arrays, effects of ground near antennas, there should be some way for a fellow to figure out which episode of Ham College.
Have I got something for you?
Oh?
Yeah?
Do tell.
You can go to AmateurLogic.TV/wiki. And if you scroll down to the bottom, you'll see show notes for Amateur Logic and Ham College on there. So you can search for your search terms there for whatever you're looking for. And if we covered it, should pop up in the search results.
Well, all my questions have been answered.
That's what I'm here for.
We promised questions at the beginning. There's your answer.
There you go.
Right there.
All the answers you ever wanted.
Yep.
Probably some questions you ever wanted too. Or never wanted.
7-3, everybody.
Yep. 7-3, everybody. We'll see you next week for Amateur Logic. Some of you.